Hello everyone, we're looking at question 3 of winter 2008 paper 4 9702. The question reads, the needle of a sewing machine is made to oscillate vertically through a total distance of 22 millimeter as shown in figure 3.1. The oscillations are simple harmonic with frequency of 4.5 Hz. The cloth that is being sewn is positioned 8 millimeter below the point of the needle when the needle is at its maximum height. State what is meant by simple harmonic motion. Pretty simple. We know that simple harmonic motion is based on relationship between two things, that is acceleration and the displacement, and that they are proportional to each other but they're in opposite direction. So what we will say is the displacement from a fixed point is directly proportional to acceleration from a fixed point but in opposite direction. And that is it. Moving on, we have the B part that says the displacement y of the point of the needle may be represented by the equation y equals a cos omega t. Suggest the position of the point of the needle at time equals 0. First thing what I would want you to do is immediately write down the three equations that concern the simple harmonic motion, and these three equations are something that are frequently used in these questions, and these are here. X is equals to x naught sine omega t, v equals omega x naught cos omega t, acceleration is equals to minus omega square x naught sine omega t. Now all you have to do is judge which one will be used. Now they've said that it's displacement, so I know immediately that I will be using this one. X is equals to x naught sine omega t because we're dealing with displacement here. Now if I look here, it's cos here, it's sine here. The reason why they have been flipped is because if it's starting from equilibrium, you write sine. However, if it's starting from amplitude, that is when you use cos here. But that is not our concern here. Our concern here is to substitute these with our original one. If you look, we have y, we can write this as x, and then we have our a, which is x naught, which is is amplitude, and then you have cos omega t, sine omega t, doesn't matter. Now if they say at time t equals 0, when you make t equals 0, this multiplies with omega, this multiplies with cos, you will get 0 and this will cancel out. When this cancels out, you're left with this, y equals a. And they're saying suggest the position. So obviously we know x is going to equal to x naught, because when you have 0 and when you multiply this with omega, cos of 0 is 1, so you're gonna get 1 into a. So we can say the final equation we will be getting is x is equals to x naught, which means when this is suggest the position, we will say that it is at its maximum height. Yeah, we can say it will be at its amplitude, at its maximum heights, in simple words. And moving on towards second part, determine the values of a and omega. Now this one more question is something that confuses students a lot, We know what A is. A is our amplitude. But how do we know what amplitude is? They have given us a total distance. We do not know what the amplitude is. If this confuses you, one thing I would suggest you to make things easier for yourself is think of it as a wave, because it's easier to see the amplitude when you're dealing with waves. Let's say we have this one wave here. We know this is our amplitude, this is our equilibrium position, and then again this is our amplitude as well. They say it is oscillating vertically through a total distance of 22 millimeter. That means the wave started from equilibrium, it went up and then it went down, and this entire distance was 22. If this entire distance was 22, how about this one? How about this one? That means if I divide this by 2, I will get 11. I will get 11. Because only then I can say that if this was 11 above, it was 11 down, and so when you add these two, you will get the total distance, that is 22. So I can say that the amplitude is 11 millimeter. So you will write 11 millimeter. Now omega, pretty simple. You know omega is 2 pi f or 2 pi by t, depending on what they have given to you. In this case, they have given us the frequency, which is 4.5, so you will simply just write 2 pi f. It's extremely important that you write down the formula first, because they can cut your marks, or you might get something wrong in your calculations, but you can still get a mark for your formula. So you have 2 pi into frequency, which was 4.5, and when you multiply this, you will be getting 28.3. Moving on with the C part that says calculate for the point of the needle its maximum speed. Again, every single time you hear the word maximum, you should immediately think of the formula V equals omega x naught. Now, the reason why I'm not writing cos omega t is because when you're dealing with maximum, the word maximum says that you can only write this formula. You can skip cos omega t and you can write V equals omega x naught. Now I know what omega is, that is 28.3. 28.3 multiply x naught, which is my amplitude, which was 11 millimeter. Since it's in meter per second, so I have to convert millimeter into meter, which is 11 into 10 raised to the power 11 into 10 raised to the power minus 3, and you should be getting 0.3. And now the second part, its speed as it moves downwards through the cloth. First thing I would want you to is identify the formula that you will be using. Now it doesn't say maximum speed, so I have two options. I can use V equals omega x naught cos omega t, or I can have V equals plus minus omega x naught square minus x square. Now how do we identify which one to use? Have they given you time? No, you can ultimately cut this out. And the reason why I'm writing cos omega t is because they haven't written the maximum speed, so I have to mention this. In this part they had written maximum, so I had omitted this cos omega t. So I can cut this out because I do not know what T is. Let's look at this formula. This formula is usually used when they haven't given, you do not have T. We have omega, we have x naught. What about x square? We have to find the displacement. Its speed as it moves downwards through the cloth. Let's go back and we have to find the distance. Again, if you look at this, it will just confuse you out. You can look at this, and I'll make this again for your simplicity. It says the cloth that is being sewn is positioned 8 millimeter below the point of the needle when the needle is at its maximum height. So when you're looking for displacement x, you have to look at it from the equilibrium position. Always, you always look for the displacement from the equilibrium position. So let's assume that this is my wave, and this is this right here is my equilibrium position. Now they say we have to find out the displacement as it goes through the cloth, and it is positioned 8 millimeter below the point of the needle when the needle is at its maximum height. Its maximum height is right here, and we know the maximum height is 11, but we also know that the cloth is 8 millimeter below the point of the needle. They're saying that when the needle is at its maximum height, the cloth is 8 millimeter below. The cloth is, let's assume, somewhere here. What is this distance from the equilibrium position? This is 8. What is this? The total is 11. We have this, we have to find this. 11 minus 8 will give you 3. We will say it is 3 millimeter above the equilibrium position. And I hope that makes sense, because it's extremely important to understand this, and you can better understand this if you visualize it using this. If I were to explain it again in simple words, number one thing that you need to understand is displacement is always from an equilibrium position. So this is my equilibrium position. Number two, they say that it is below the point when the needle is at its maximum height. I know its maximum height is here, that is 11 millimeter. And they say and the cloth is positioned 8 millimeter below. So if this is the maximum height, you go 8 millimeter below, and this is where my oopsies, I'll just stuck with this then. And this is where my cloth is placed. What about this part? This is what they have to find, because they are saying through the cloth. So if this was the cloth, it has to move through the cloth. Only 3 millimeter is left, so our displacement is 3 millimeter. And simply all you have to do now is omega is 28.3 under root our x naught, which is 11 into 10 raised to the power or you can just simply write 11 square minus 3 square. It's up to you. And you multiply this with 10 raised to minus 3, and then your answer that you should be getting is 0.3. And this is it for question number 3.